hopefully we're back sound wise, but that camera is still not. Why is that camera? Okay, I don't know why I'm having to stop and start the camera. So is everybody back with me? So I think just restarting that did fix whatever the deal was, because I did jump over to the full display before I started or turned the stream back on. Hey, Shrimp Father, welcome on in. So give me 1 second. I'm going to jump back over here. So I'm hearing the. We getting sound? Test, test, test. Do we have sound now? Yeah, the sound effect is working. I'm seeing that the mic's getting picked up now. Can you hear me? Yes or no? You've heard something quiet though. Hear you now. Exactly. I switched this weekend on Sunday. I switched from Windows 10 up to Windows. I have a feeling that it's doing something in the background again. I have to go and allow a whole crap. And thank you for the follow, Piled 3D. Thank you, thank you. Hey, Elite. So I think I'm going to stay on my main scenes, hopefully. So anyhow, what I was trying to say was, got your connection from the TFT over to your Raspberry Pi. Normally has the 4 pins, 4, 5 volt, and 6 is ground, and 5, 8, and 10 are transmit and receive. Roll that pair between the two boards. Ground to ground, power to power, What I did was I brought another power line. It's currently blue. I need to change it to red from pin 2 to 5 volt of the SPI jumper. Got, bring you guys. So we've got our EXP header. There is 5 volt here, but it's this bottom left hand header. Kind of too long for. So there is a 5 volt here. That's where I've plugged into. Well, and that's the thing. They're going to force push 11 because they're going to stop doing 10 and they're going to force push 11. SolidWorks. Gotcha. Yeah, so that's what I'm trying to do is I'll be trying to figure some of that. So what I'm going to do is this have this address it pulled yesterday. And it does. So let me bring up hopefully okay, so looks like we still have audio on this one. And hopefully you can see down here in the bottom right. Enable the secure boot thing before installing Windows. That's true. Problem is Windows 10 getting ready to stop doing any type of patching unless you pay for extended support. So going up to Windows 11 probably not a bad thing, but it depends on your use. So yeah, if you depend on SolidWorks and SolidWorks doesn't work, then of course you're going to keep it around. Trust me, there's a lot of people still running Windows 95 and Mach 3. A lot of medical devices still running Windows 95. Not a good thing, but it's what's happening, right? You had to hack this for Windows 11 since technically supported hardware seems to. Would you have to have stopped all dates because software? The way folks are going, I may return this Office to clone the hard drive before I put Windows. Yeah, exactly. So Timor Mrs. Dragon picked up Dunkin' for me. And in fact, I will tell you this: I got coffee. I didn't get donuts. Now, that being said, on the stream talking about did pick up an order from Nothing Bundt Cake. Got their lemon raspberry. So you were at the hotel out at Murph. You know what I'm talking about when I say Nothing Bundt. Is fabulous. Okay, so what you're seeing here is an MC shutdown EDC out of range. That is perfect. Okay, the reason that's perfect is it says that one of your temperatures is the configured min or max temp. Okay, here's the thing: we currently only have a thermistor from the bed and don't have a thermistor running for our tool head. And you know how I solved this? A cheap pack of 3950 thermistors off AliExpress. 5 in here. Currently, there's only 4 because I pulled one out because my plan is to swap this for the default thermistor that came with the tool head if I out because it means tearing the tool head apart, but that way I don't have to try and extend those wires by soldering. We'll have to solder the wires for the hot or the heater itself simply because I got microfit. I don't have any female 2-pin connector for the microfit. I'd have to, and I don't have any 2/2. I'd have to do like 4 sideways or something like that. It's not going to work out. So I'm just going to do the solder joints like we did for the fans. But what I can do is take one of these right? Our thermistors are down here, so our last thermistor is the last one down here. I'm going to take one of these thermistors and plug it in. And I'm going to do a firmware restart. Patched ISO with Rufus install tool. Yeah, oh yeah, Rufus is an awesome tool to have. Okay, and as you can see, it has now come up. And it's reading approximately the same between the extruder, which is a thermistor bundled in here, and the bed, which is physically a thermistor, screw in thermistor at the bottom of the polyamide. Hey, Zombie, how's it going? Yeah, gotcha. So by plugging in a thermistor, I know that the board itself works and I have a basic config. So in the last stream, I realized I hadn't posted until today, so it's now been posted. Um, we went through the software config. So we went through the software config. We installed just the base Raspbian OS, and then went through and installed Kaya and installed everything. As soon as I did the install for a Clipper screen, things went south and it stopped working. So after stream, I went through and said, the heck with it, put mainsail OS on it, it was working, put Kaya on there and installed Clipper screen, it stopped working. So here's the issue. One, there's a couple of lines that you add to your Raspberry Pi and manline.txt, big.txt. Those are called out in the Bigtree Tech GitHub for the 4.3 display that we're going to. The other thing, this is something that I wasn't picking up on because, you know, who reads little messages pop up selling something? Well, one of those messages says, depending on how you set your network up, you may have to rejoin the network using your Clipper screen display. That was the issue. All of a sudden, I thought something was broken because I couldn't log in, and this was on the network. What the hell? Well, I plugged the Clipper screen display in. Clipper screen came up. I went to more, and I went to the network and realized that the network was not connected. I didn't have to put anything in. I basically just had select one of my network. I selected the network. It came up on the network. I could then. So that's the thing. So I haven't seen Tugboat on here. So Tugboat, when you're reviewing this, just note everything may be working, right? Make sure that you get your Bigtree Tech display connected. And this is an interesting little display case. I will link to this. I still need to try and wipe this down with some acetone. This leftover vision mine. But you'll notice these hard white lines here. That is because this case prints all the way flat and you fold the sides in and then you mount the two mounting brackets using the screws from the Bigtree Tech kit straight down through the little like 1 or 2 layer eyelet. And now what we're going to do is we're going to mount this to the front of our printer, and it's going to sit proud of the bottom. So we don't have to do some really crazy, like on my current Rook 2020, I've got like a 60-degree angle. It sits out here like this because it's mounting underneath. And you have to have it at a very obtuse angle to be able to sit there, not get bent up when the printer's sitting on a flat surface. So I'll send the files over to you for this tugboat, and you can print this out. Don't worry about making it color match. Print it out in straight black or do a dark gray. If you want, ask me, and I can either do it in blue or the nanotube gray. I've got plenty of it. I can ship that to you. There's one other thing that I'm probably going to have to ship to you as well. So these two ears, exactly the same. This ear and this ear, they're the same file. Which means if you put this one in the same orientation where it's flat on the back, has the little jog out in the front, it's going to be down here versus up here where you need it. So one of these needed to be mirrored. So they actually don't have the mirrored print. So you have to invert them yourself in the slicer. You only install 3. Exactly. So right now I've got 3. And the way I was looking is it shows the flat side as facing the mesh side of this, which in essence recesses this into the printer a little bit. That'll work great if you're running a Raspberry Pi Zero, not if you're running one of these. You're going to have to do some standoff. So flipping it over so the flat side goes against the flat side of the back here, it's just going to be touching your USB. So what I'm going to do is put some Kapton tape back here to electrically isolate it because it's going to touch. Other thing, and I just noticed this as I was sitting here before stream saying, how's this going to work? You need to put heat set inserts in these feet so that we can then have a spot that we can screw through the tab and into the feet. So I did not see that before. Otherwise, we would have put heat sets in at a time. And that also means your wiring here has to be kind of looped down just like that because of the way this is going to fit. So it's a good thing that we put one of those little 4-way tie downs here. And we're going to have to tie this down so it's out of the way. So just a couple of things to point out. So I wanted to show this to you guys. We do need to shut this back off so that we can actually do the rest of the physical install of. Shut this down. We're going to give it a couple of seconds to do its little read-write operations. Okay, got the little flashy went away. We're going to turn this off and pull power. And like I said, there's a couple of things that we need to work on. I had to install it your way too, mainly so open terminals were. Yeah. So installing it this way, I'm going to install it this way. So the terminals are still going to be over here, but I do have the little cover for it. In tugboats, you can mount it like this so that the terminals are facing the side of the printer. But the other thing to remember, you have it like this, you're going to put the cover on it. You're going to have side skirt as well. So just be cognizant. So I think what I want to do right now is because we're set up this way, I want to go ahead and do this Z-axis before I add any more stuff. So what I'm going to do so that we can just see a little bit more. Because once again, we've got our big pulley We'll have our standard 22 pulley. We'll have our belt, this same belt from the other printer. This one should still work because the Z-axis hasn't really changed much. If it doesn't work, if it's not long enough, then we have the A and B belts from the previous build to use, or we can use some fresh belt. It does, but your A and B belts are going to be too short with the belt routing, so just something to be aware of. The other thing I'm going to need is a D shaft, and so the quickest way to get them here was just to order. This is basically a Boron 2.4 Z motor pack. So we've got the 4 60mm D shafts, and then the one shaft that would go on the sex bolt for the initial bed and stop. I think what it turns or winds up being. So what we're going to have to do is we're going to slide this, and it's going to go through that one flanged bearing that we have in here, through our 22 pulley, and then into the other flange bearing, and it shouldn't protrude any. If it's going to protrude any, I want it to protrude on this side because I've got wires down. Don't need anything turning up wires. What I do need to do, however, is just figure out which way the fat part of our pulley needs to be facing the back side of the print. That'll give us, first, we need to get this going through our flange bearing. Get it through the flange. This goes through our flange. Slide our pulley over here. Slide our flange bearing. At the very least, get it on top of the pulley. Use the pulley to pull it back. Probably one of those things that if you were this definitely would have been a lot easier to do before we mounted this foot. A lot easier to get working. Okay. Got our pulley in there. What I'm going to do is line this up on the flat down. That to put the flange back in place. flange bearings just what is what. Have to start using gravity as our friend again. Apparently some freezers. We'll adjust this belt as needed. This one is going to go with the belt to the inside of the printer and our locking pieces on the outside. Got to make sure as we get this on here, get this belt loop. And I may wind up needing to take this completely back out and reinstalling it simply because there's not enough movement or travel. Yeah, it's been a little while, Dulcifer, hasn't it? It was probably one of the last Rook builds I did. It's been a little bit since I've done a Rook build. Now, let's see if I got, still don't have enough movement. So I'm going to have to take that third bolt out. Hidden behind this pulley. This is going to be fun. Okay. Large pulley. Full belt. There we go. Going to line up. Yeah, based on this, I would have much rather have had these parts and installed these parts prior to even like I would have installed this on the foot before installing the foot on the darn printer. I would have had more area to play around with and work with. that is up as a this one that becomes your pivot, hard to get to and keep aligned so that you can even with a ball in. There we go. Now, I'm going to just rotate this down and around, and that's going to tighten up this belt. Doesn't take a lot. You're not trying to ugga-dugga this like crazy, because all you're going to do is add the additional, add additional torque to try and get this to rotate. And I probably should have lined that up on the flat before tensioning the belt down, where I can still kind of turn some. Belts are lined up. Lock down your M3 lock nuts and starting on the flat. Hey, Rodney Mac, how's it going? Long time to see. On my Twitter helps it. Yeah. Okay. That's there. That's there. That's probably not lined up, but we'll fix that as we go. Go ahead and get this tensioned again. Lock down. That's done. So now what we need to do is route our belt, and our belt's going to go around this pulley up and into our base here. And don't have a belt pad. Oh, hey, Gulfspur, thank you for the 5 bits. I appreciate it. Go ahead and that. So, oh yeah. So in our belt path here, we've got so on our z-axis, yes, you'll notice that these are these are tabs, top and bottom. So that's where you're going to loop your V-belt or zip tie it, just like we did gantry belt, right? So we're going to loop around that peg, bring it down, lock our belts together, then zip tie. Okay, top and bottom, and that'll provide a nice, easy belting method. And as you can see, in all the way up, we've got plenty of gap between the top of the bed and the pulley here, and we're fully up against tool heads. Yeah, that's, we're not going to bottom out the bed and risk getting the belt caught. So what we'll do is figure out which way our wording is. Thanks, Steve. We're going to loop this down and just use a pair of tweezers to grab that tail end, kind of bring it back up through the top here. Remember how much fun this was. So we're just making our belt, loop around that. Just have our belt looped around that piece there. And we're going to line our teeth up, and we're just going to put a couple of zip ties on it. Lined up, cinch that tight, and I tend to go opposite directions with my zip ties when I do this. I can try and snug them up as close as possible to each other. Like that, we've got our two zip ties. Snip those ends. How are you doing today, Liz? All is doing well. Happy Taco Tuesday, and I didn't get any tacos as a try. Okay, so we come around our top belt, top pulley up here. Okay, going to fish this down through the left-hand side over here, which is a straight shot down through the part, like so. And we'll set this back on its face. That way we can take the weight of the bed off for us. We'll run this down through the pulley area. What that's going to do is allow us to figure out where our pulley needs to go. Our pulley needs to be pulled all the way up again. Top flange bearing. Unscrew it here, then unscrew the other side, up the other side. We can pull our pulley up into the right location. flange bearings are being annoying, not staying. Should be. I may wind up put a little bit of a blocking material, otherwise known as super glue. On the flange where the flange hits the printed part. Put a little bit of super glue. Help hold it. Hey, Free Heathen, how you doing, sir? My bearings are starting to annoy me. I either lose my bearings or they piss me off. Tell you what. And I need to just, sorry, let me do something here. Then I'll pull you guys up. So I just need to get a little bit more height on this so that work on getting my bearings. So we have a flange bearing, but it's not a solid sandwich between bearings and the 22 we're using belt. And if we don't have our bearings in there, our 5mm rod is not going to be straight and supported on both sides. That's I'm going to scream a little bit later. Try not to scream. As I said, try. Definitely going to try my patience here. Shaft between those two bearings, because it's not a solid fit, I'm wondering, ooh, that's something. Look at the CAD roll. I'm wondering, browser window, browser window. Over in Here's the belt. That's a spacer. That's what we're missing is a spacer. And my thought was, I wonder if I need to put um I was wondering if I needed to put a 608 bearing or something. Yeah, there definitely needs to be something there to make that more of a switch. Um, how are you doing, Maker Millwright? Free Heathen? Doing good today? Doing quasi good. He built slightly annoying, right? But for no other reason than trying to get the darn flanges, the flange bearings to stay in place and everything. Apparently there was a spacer that I did not see. Feels like there is a burr somewhere. Seriously. Hanging up, trying to pull it through the flange bearing. Of course, now I don't have the space to get the bearing maybe. Off one. Or question about I need one piece. Oh, of course, I'm not going to have enough slack to get any of the other pieces. There we go. That was joy. Okay. So it requires some type of spacer, and oh, like, where's my box? Printer's on the box that I was looking for. Even here, I did have some printed spacers. Currently not. What did I do with the box? Bag of printed spacers. People like throw them out. Not appear to be the case. Okay, so I guess I'll go back to my other thought, which was 608 bearing. Actually, I need a 5mm. It would just, oh, darn it. Why? We're so close and yet so far away. What games you playing, Free Heathen? You out there playing whatchamacallit? Helldivers? Why do I do this to myself, folks? I know there were spacers. They were in there with the brackets for the power supply. My other standard space have that would be for things like a Prusa bed. I don't know if they would fit or if they would be too big. I'll have to see, because I do see one of those right here. Seeing that can to get to. Definitely go around the 5mm shaft. Spacer that I'll try and use right here. Wondering if what I was catching on was where I had driven the set screws up against it. Might have been where I was catching on. Let me grab my sandpaper, the used one. Just slightly give this a twist or two. Not trying to really change the diameter massively. I'm just trying to give myself a little bit of extra. Okay. There's still some We're going to have to do this the standard Voron way. Tuck up your D shaft. Grab your sandpaper and burn it. Shouldn't take much. Those are better. Do that after. Okay. So one of these goes in the bottom. Nicely pressed in. Goes in this top. Also nicely pressed in. And like I said, there's a part of me that's like seriously thinking like, do I go ahead and put a little dab of Loctite? This is showing the belt going down to the. I didn't think that was a good alignment with the all the way down at the bottom. Let me take another look. Round. Does work. Be looking at putting this at the top between the top flange bearing and the between the top flange bearing and our pulley, be that spacer that would kind of hold everything together in the right spot. Get that somewhat closely lined up, and then start putting the shaft in. Up as we work our way down. Go. That so that it lines up on the flat. Side. Okay. Now, larger pulley and the other belt. This slipped on without having. lots of our shafts up. So pulley again. This motor up. All said and done, we should have tensioned the axis. Just drop down a little bit. About one of the issues I'm having is just trying to get these two lined up, same height. Bit of play here because I think this top pulley fell down again, which means now there's play. Top pulley, bottom one is in place. Okay, so I think I know what I need. Is screwdriver. Oops. I think we're good. Alt. And it's going to be too short. So it doesn't look like our Z belt will work. That sucks. So we're going to need to use a different belt for our Z belt. Go back, like I said, and grab the A or B belt from this build a little bit longer. So we'll have to get these zip ties off up here. So that belt's not going to work. What did I do with the other two? No, but here's some other Gates power grip. This could be plenty long enough, so enough for me. What I'm going to do is I'm just going to push this up through the bottom. Work it around here. Ah. In my tweezers right now, but I think I used a zip tie originally. Basically, all you need is something that you can use to guide the belt back up and around. There are tweezers, zip tie, anything like that. You're just trying to guide that belt back up and get it back up and around. You don't need a huge amount, but you don't want to make it too short because service loop for later on. Do zip ties again. Hey, Westry, how are you doing? Hope you are doing well. We're having fun here. We're working on the Rook build. Um, just finally got the Z belt installed finally and realized that it was going to be too short. Pop it back off, and we're going with a different piece of belt. How are you and Mia doing tonight? Recovering? Recovering from what? Travel? Okay. So loop this up around our pulley. Tail back through. News is we should have plenty of belt to mess with here. Same type of thing. Come in top. Guide the belt back around the there we go. Was becoming full. Okay. around there. And remember, at this point, we haven't tensioned our Z because we don't have any screws at the top. So just trying to get it manually close. You don't have to like really yank and crank on it. Those two are. Now we've got a lot more slack there than I thought I was leaving. I'm going to tighten that up at least another notch. Guys. And if you build printers enough, yeah, just go and get a big supply of zip ties. Different sizes. You'll need them. Add the flue. Well, that's not good. Now I'm going to go ahead and cut some of this excess. So I can get it out of the way. And like I said, we're not going to be like strumming this, but we do want it to be fairly tight. Okay, now we've got our Z motor in place, and you'll notice because it's a belted Z, that our bed stays up. We actually have to push it down, not a belted Z, but a belted Z. Still not 100% tight, so skipping one. We'll be able to put our screws in here. We're going to need to put some heat sets in as well. And darn it, I forgot to do that beforehand. So we get to do that now as well. We're going to have to do some heat sets. So put these away. And I should have done that before I mounted this. But we'll be able to do a couple of different heat sets all at once now. Because what we need to do is out of the way. We're going to need to put heat sets underneath here so that we can run screws through. So at this top, we've got a spot for 4 screws. Right? And these are going to go on the edges of the rail and push up. Well, the only way it's going to do that is if these have heat sets in them. We need to put the heat sets in from the bottom of this. So we probably needed to do that before. Just ran the belt. I forgot. So that's not at the bottom. I'm going to undo these 2 bolts. Out. Go ahead and we'll put in our 4 heat sets right here. These are going to be M3 heat sets. So then once we get these done, we'll also fit this up. I'll pop this out and we'll do the 4 into the leg. So we'll be able to screw in our power supply. Then we're going to need to take our tool head apart, which shouldn't be that hard. But we'll take our tool head apart. That will allow us to get in and swap the thermistor out for a long run thermistor, and we'll be able to have the room to cut these ends and put in a that really. So what just happened was I turned that on, did not realize I still had an M5 heat. I have to wait a couple of minutes for that to cool off so that I can swap that M5 out for the. Meanwhile, we're going to work on taking our tool head apart, and for the way our tool head goes together, we have 1 screw that comes in from the back on our tool head. Take that screw out. And that should allow our entire tool head to come off. Okay. Back. Drop them. Seriously, drop. Screws out of the back. Do the 2 front. That will allow my front fan to come. Front fan shroud. Need to get our tool head apart. In our way back. And I'm going to take our whole tool head out. Take our off. Now, sorry to hear that you had the flu. Hopefully you're feeling a lot better, sis. There's our extruder coming well. And I'm going to try and set this stuff down. Because what we need to do is take our hot end out. Hot end, we can pull back. Alrighty, drop some more screws. That's going to be fun to find later. One of them. Okay. Now what we're going to try and do is basically disassemble our hot end again. You need to take the sock off carefully. That's easy. Any the wires. Now, what we're trying to get to is our thermistor. Feed thermistors right here on the side. We've got the clip, so we need to try and bring our clip off the top of our hot end. I'm just slowly wiggling it down. And all I need to do is get it far enough to expose the thermistor. What that will allow me to do, different bead thermistor, and put it in there. Now, knowing that this has to go down and through this top piece here, I'm going to go ahead and try and route that down so I don't have to try and depin it and deal with all the pins. So, bead thermistor, back down into the hot end. So this bead thermistor not fit in there. Are you serious? All right, so Apparently that's not going to work, and we're just going to have to solder everything up. That just sucks. That just sucks. But it is what it is. It is life. That back in there. Back up, and I go back through and assemble our hot end again. Carefully and gently. That kind of sucks. We're going to have to cut off the ends and solder all of these because they're definitely different. Well, the heater had a JST on it. The other one had like some stupid small JST. And my preference would be not to use this. Just gonna get the fiddly ends back through here. Somewhat complicated by me not wanting to just cut these, getting the 4 wires split at the top. Probably be a little bit easier. Wires up as we pull our hot end into place. Put our screws back in. And once again, be careful of that heat break. It's very, very small and very, very easy to break that heat. Put in the wrong one. So loads of fun. We got to take our tool head apart. You get to see what happens if you got to take things apart. Thank you for the lurk. Enjoy your phone call, Westry. Back on our hot end. So probably would have been better to do that again before we had installed it back on hot end. Tool head is what it is. So we got that done. We need to do our fan plate again. 8 screws and 3x8 screws. Oh, that's the that's the one. That is the one that I don't know. Yeah, well, I think I saw it. I tried to grab it. Where I thought it was. Eh, somewhere down in the filament racks. So we'll grab an M3 by 8, black one. Calling that take our fan shroud and shroud. Fill it back with our long bolts. No idea what the length is. They refer back to the previous video. Now, before I go through and put my extruder back on, I'm going to want to solder on the extensions and make some extensions. So I'm going to pass this through here so I have much room as possible to work on the front of this. We need to swap out this for heat sets. Think real. Probably want to do this first because we'll do that with a heat gun. Get that back installed because we're going to need to do heat sets down here too, so it makes no sense to heat that up. Do a couple and then have to stop, do this, and do other things. So fun. I was so thinking, oh, this is going to flash by real fast, and then boom, we'll be printing in no time. And I should know better because every time I think like that, something creeps in and it's like, oh, nope, we got to do this or we got to do that. I was like, oh, this will be an easy swap to do this. Famous last words. That and going to 20 gauge. For our hot end. Just going to unwind a bit here. Quite honestly, I'm just going to make this long off. rid of the. Like I said, I'm probably going to make this way too long. Rather have it too long and have to cut some off than too short and have to redo it again. I'm going to do this with uh, both sides black because it does not matter. This is not a polarized connection um, for the hot end. And then we'll do the same thing for the thermistor. I'll just make it some other wire color. Oh, maybe I'll just cut the glass bead off that one and reuse it. A little bit off of these ends. Need to cut the ends off this. See, um, like I said, all we're going to do is cut the existing fasteners off here, strip a length, use our fireflies, and shrink solder these together. Now, normally these would be like a JST directly into a board on, a toolhead board. That length would probably work just fine in doing JSTs. I don't have a kit to make. I don't have a kit to make JSTs that are the pen side, female connector, male pen side of them. The only way I can do that is to do solder joints. And if I do solder joints, I'm just going to solder it like this. The other ones are just kind of, I'll say, a pain to do and do well. So that just, oh, so that whole thing just came off. That's, oh my. That's one way to do it is to pull the insulation completely off the wire, cut a little bit off the insulation, push it back down on the wire. one way to that's one way to get your strip some wire, right? Side. Side now. Had to recover your printables account. Uh-oh. Ah, yeah. Yeah, switching phones in the authenticator app, that is the most annoying thing. I mean, I get it. I understand it. I'm a computer security guy by trade, but yeah, that is annoying. Got like 40 frippin' accounts with authenticators, that you use the authenticator app for. It's even more of a pain. Hey, Chewy, how's it going? Lurking and printing. Okay. Hopefully printing with a 2.4, since you have one of those now. We're trying to get there. I was hoping to be there by now. Okay, so those two should be done. We'll need to do the other two, and quite honestly, the other two, um, we're gonna run that in. Let's do black. Like I said, we could run it in that, but run it in long length of black gauge. This is a thermistor wire. It's not a high voltage wire. It does massive hooks. Not going to be like going, not like a 2.4. So probably going to be overkill. So what I'm doing right now, Gulsifer, is the hot end for this is a Bamboo Lab clone hot end. It's what was called out for in the bomb, and it's got very short connectors for tool heads that need to be extended. So that's what I'm doing right now is I'm extending those wires out. I wanted to use Microfit 3 connectors, and Evil Diesel had my Microfit kit. So I got that back from them. But the issue is I don't have the female side of the connectors to actually make the the two pin connectors for these. So I'm basically having to just go ahead and extend them out with standard wires. And so my thought process was, well, if I'm going to have to extend these out anyhow, how about if I just use a pre-made thermistor cable? And the problem with that is the pre-made thermistor cable, the glass bead thermistor head is too big to go into the hole that's inside of this. I was hoping for simple. It's not simple. So now I'm having to sit here and extend these wires, and it's just a pain in the butt. And God's honest truth, these, I'm not going to cut these off. I'm just going to solder them the way these are, because those things are like JST, like H, or probably even smaller. So I'm just going to leave those the way they are, solder those with those tiny pins. Once again, I'm just using a pair of black 24 gauge FEP wires for this thermistor. Doesn't need to be anything super heavy, because it's not a power, it's not like accepting power. So it doesn't need to be anything super crazy. Yeah, the white ones, I believe, are still our smallest option. Like I said, these are heat shrink connectors, and all you're trying to do is get the metal wire, the stripped wire in the center. We'll shrink down both sides around the wire so that it doesn't go anywhere. And then concentrate on the middle to melt that solder. Once the solder flows, just go ahead and remove your, and let it cool back down. What's up with this new BQ H2 extruder for the stealth burner? I don't know. I don't know. I know that they've been dropping hints about new stuff. they've also listed a they're basically teasing a USB EBB 36, or I'm sorry, EBB SB 2209 with 3 underlines. So they're teasing a USB for it, aka the Nighthawk Stealth Burner in a Big Tree Tech board. And I've got 4 Nighthawks sitting over here in the corner that I need to start swapping into printers. Y'all feel free to let me know if that's something that you guys would be interested in seeing me do, is swap the a Stealth Burner CAN bus over to Nighthawk, which is basically, like I said, going to go to a USB connector and get rid of the CAN bus requirement, so we can move a UTC if we were doing it and stuff like that. So God bless. Once this thing starts heating up, it doesn't hold its. That over there on something that's not going to melt. Go ahead and start getting this, our heat press, going. We'll get these heat press pushed down in there. So we'll need to make sure that we've got good conductivity, especially on the thermistor. I know we're good on the on our larger wires. It's more of, did I get a good connection on these wires? And the easiest way to do that is just going to be terminate it and run it to the back. Slide these wires around. Okay, that will bring it around. That up there. Still have my back and one for got our 2 screws back here to hold our fan shrouds in place. We'll have the 1 screw that comes in from the back that holds it to the carriage mount. Bring our screw back up. Okay. Be able to bring these all together in a bit of a sleeve here at the top. I still need to print something out to provide some strain relief at the back side of this. Bring all this up. Do a little bit of a loom right here. Oh, for right now, I might just zip tie some things together rather than mess with the, because I want to get printing. These need to be partially countersunk, so that we can get it nice and tied up against the rail. That's the 4 that we needed right there. That way, when we screw in through here, it has something tied into the part and raise this part up to provide tension on our. Up. Then our 5 volts. We're getting a little bit of belt slipping. There. So we do need to put some screws in here and raise it up just a little bit. Gonna need to add some screws at the that's at let me face down, and I'm just going to put these in manually real fast. That if I had realized it beforehand, we would have set those in when we had the board, or we had um, the ability to do them with the correct heat sets, or the correct heat. When we had the ability to use the press, now we don't have the ability to use the press. Based are already installed, and we're not run that up, out, and I'm just going to press these in without melting a foot. So I'm getting these close, and then I'm using the tweezer to make sure they're nice and flat. And I've got to be careful on this side because I've got a lot of wires over here. I would not suggest doing what I just did. Don't worry, I'm probably going to do it as I say. What I'm doing right now is I'm adding a heat set at the bottom of the foot that's going to allow me to screw the power supply to the feet. Okay. That down there. Back down here. Oh, okay. Hey, Aaron F. Geared, welcome on in. Welcome on in. And yeah, like I said, I've got a couple of things that I picked up at Murph. So KB3D, I'm going to let this stuff cool down before I start digging around in there because I know myself. I burn myself if I. So at Murph, I picked up 4 of these Nighthawk tool boards and all kinds of connectors, screws, the toolhead PCBs. Okay, so we have the toolhead piece. This is the same form factor as standard. Going to mount in the same holes. Basically, unplug everything. You pull the SB22 line out. And here's the thing. Here's the board for the fan side. Yes, it has the pretty connectors in it and stuff. This is the same board. Meaning this pinout right here is the exact same as the standard, as any of the standard self burner toolhead boards. So you technically don't need to pop the old one out, put this one on, and re-terminate to make the same connectors. You can just put this in and it pops right, the whole front panel pops right back on. Yeah. So, you know, this has your thermistor. You've got a somewhat smallish, but not as small as like the EBB 36 screw downs. So these are good screw downs still. You use some ferrules in here. And you've still got an XT30 by 2 connector, but it's not the same cable. Okay? Just be aware you cannot use the same cable. I say that because the opposite end, you still have some type of interface cable. It's just not a it's not a UTC. In this case, it is a USB extension board out there. So you'll have a USB-C connector goes to your Raspberry Pi. Okay. You'll have a screw down terminal to supply 24 volts to this board, similar to a UTC. Then you have a 6-pin. This is going to bring, what is it? You get power and ground. So 24 volt and ground. Then the other side is the USB side of the cable, which will bring, I think it's power, ground, and signaling. That's why you're using a 6-pin instead of a 4-pin. Now the cable's already created for you. You do not have to recreate that cable unless you're wanting to shorten it. And I'm sure that this is made so that it'll work for a 200, or I'm sorry, a 250, a 300, or a 350, right? So depending on what you're going to use this on, you're probably going to want to shorten that or loop it around and hold it out of the way. But that cable is in here. Like I said, it's pre-made. There's your USB-A to USB-C. There's your XT30 plus 2. So this is the power, the 24 volt power, and the USB bus communication. There's your pigtail pre-made to bring your power to that other board. And there's your 6-pin connector. And yeah, it is connecting 5 wires up. So it looks like 2 grounds, a positive, and then the data line. So you are getting 2 grounds that are most likely being joined to the ground side over here. So nice, good. And this is cable chain rated. So if you're already running cable chains, you do not have to like go to an umbilical. You can leave your cable chains on if you so desire. Like my LDO 300 size 2.4, I'm running the cable chain. I'm going to be able to take out all the cable chain, or not the cable chain, but take all the cables out and just run this through the existing cable chain with no issue. So we probably won't be doing this on all of them, but we may do one of these on stream just because. The other thing I did was I picked up a Duet 3 Mini 5 Plus. This will be for a future build that we're going to do on stream. I haven't decided which one yet, but it's going to go in something like, I don't know, maybe either a Doron Velta or a or maybe the rebuild of the Tico Tarantula. I don't know. I haven't decided yet. And then I also picked up the Duet 3 accelerometer. So, full disclosure, I bought and paid for the Duet stuff, and KB3 brought it to me. I walked away with 4 of the Stealth Burner boards. That was a kind gesture from KB3. So we did get something extra from that. Now what I'm going to do, I did say I was just going to do a couple of zip ties here rather than try and find the cable stuff. Some cable sheathing. I know I've got it around here. I just got to go find it. right now I am figure out what I do. Add some zip ties, guys. I am apparently losing my mind again. Drop them. There. There. Anybody see what I did with the zip ties? Oh, there they are. Box on top. So just so I can figure out what kind of length I need on these, we're going to kind of zip tie stuff up here together. I'm just going to kind of zip tie them all right there at the top and do a couple along the length. That will provide some initial strain relief for them. And then I will get, I will do like a full up umbilical wire wrap on them. Now I just want to try and get them joined together in holy matrimony. Burning them in line cable. A couple of other things I'm going to do because I know that these will run into the belts if I don't. I'm going to print something right here that I can zip tie it to keep it from bending into the belts. And then on the other side, or maybe right next to it, I'm going to print a reverse Bowden mount like I did for my Rook, my other Rook 2020. And that will provide an easy way of, it's an easy way of bringing things to a show and being able to easily route things. So let me just get down. Get this out of the way, and what I do is I just have the Bowden tube from the reverse Bowden coupler to the tool head, and then I can feed it right in through the back without needing any Bowden tubing. So this I'll add into the little cloth that I have here already. But what I'm going to do, make sure that I've got some space. We're going to bring this down, and our thermistor needs to come down and go here. So that right there, we'll snip that off. Not too bad. Be good for a little project board or something that I've got. Ooh, I haven't even asked. Has anybody got anything cool off of Amazon Prime deals? Is there here? This will go. This also going somewhere not here after I put a couple. So okay. Got that done. I'm going to sit down here for a minute. We're going to bring out our JST connectors, our stuff to do some wiring. We'll do a little bit of wiring here. Uh-oh, lost volume on your end. Okay. Still seeing good numbers on my side. hopefully it's should just be do the this is a standard 2-pin JST, so we just need our 2-pin JST. Lucky we can do these. And guys may be hearing behind. I've got the Mark IV print. Partly because I was going to try and do this particular print on the bamboo, realized that I need the ability for 5 colors. Do not have, well, I do have 2 AMSs. I don't have a hub, so it's not like I could, you know, join the 2 together and chaotic matrimony and run a extra multicolor print. So 5 will do for what I'm trying right now, which is save myself a little bit of time on one of the projects. Give me a second, I'll show you what I'm starting to try. One thing I hate about FEPWire tends to, it feels like it twists and get the connector lined up and crimpers. Down here, and again, this toolhead thermistor that plugged in. This is going to be the toolhead, so it's going to go right in here next to the bed. So it doesn't need to go very far, about like that. That. And got a little bit of 20 there that I can use on any type of powered circuit or there. Grab my ferrules, add some ferrules to that, and plug that in. And then it'll be on to our. Did that in one shot. So how's it going, Aaron F. Gear? Doing well tonight? Been a little while. No, I was hearing some thunder outside again tonight, even though it wasn't supposed to have any rain until tomorrow. Uh, you've been trying to print purple, but none of your printers will allow it. Interesting. I thought it was interesting that you picked Skeletor, knowing that you hate purple. About all of his stuff is has some shade of purple. Okay, that part. Well, that part. Still through these down. Terminals are already loosened. Other okay, both those make it through the tug test. Now, what I need to try and do, grab one of my and get it through that zip tie connector. You guys remember I've got those little square zip tie hold downs, and got to get our cables down. So it's going to allow me to put our cables down, keep them out of power supply. Everything doesn't have to be like super duper tight. We're just trying to, like I said, keep everything nice and neat. Kind of run it down on the side here, off. Keep it out of the way. We got our bed, got our hot end. These two pigtails come in here. This is our power coming in. This is going to loop around. Going to loop around when our hot end gets mounted. And mounting. Still need to mount our switch. Like I said, I like to do it so that my off arrow side of this facing down. That way, when I reach around back, I know I'm always going down to turn it off and up to on. So we're going to take this, route it down through here. This was pre-made because I took it off the last one. Please follow the direction for your 120. Make sure you're using insulated connectors. No chance of any um, short circuiting. The way most of these go is you have a ground, you'll have your black outside to outside, inside to inside, your red. Black and red coming out of there that go to your power supply are the same. I know a lot of people use a different color standard for their mains than their DC voltage. Black and red's normally associated with the DC voltage. Hopefully I can get this to go in this slot. See is how it was actually made for a different need to do some. Might need to do a little bit of filing. Crapola. Need to do some filing. Do it on this side so it's away from a lot of the stuff. So I want to do that there. Over here. See? Something else I probably should have done for I probably should have trial fitted that before coming in here and trying to get everything. So what do I want to do? Going to undo my Raspberry Pi just simply because the wire, or not the wire, my USB connectors are going to be facing up where I'm going to be filing. So I'm just going to pop my Raspberry Pi off here rather than file and get a whole bunch of garbage down in the USB connectors and then face issues with USB connections a while. Glad to hear that you are back in here, Nomi. Always good. Go. And now it's just a file. And once again, this could just literally be the fact that, the files are made for PLA, and I printed things in ABS. There's a different shrink rate between PLA and ABS. Okay, so there comes a time when you may need to file something to changes like that. We don't want to break this state. Naomi, how are you doing? And how was your trip, by the way? Never did get a chance to ask how your trip was. Hopefully everything went well. Just put this in the way I said I didn't want to put it in there. See if I can get it out without causing any issues, breaking. So once again, we want it so that down is off and up is on. Trying to keep this piece as tight as possible. Down and up. Power cords over here. Now we'll be able to, out of the way, we'll be able to put our Raspberry Pi back on there. Hey, Jedi Spidey, how's it going? Long time no see. Let's see. We're trying to do some more just-in-time problem solving. Get things laid out here. There is no there's not a lot of direction on cable management and wiring and routing and everything. Doing this, I kind of get a feeling like it would maybe be better to have this flip the opposite way because of my wires here, but I'm going to be able to tuck those down. Should be able to tuck them right down and around like that. Hoping. Negative, so I have to bring them around this way and around that. That's going to have to be that power stuff in place. The other thing that I want to do is one of our skirts has a place for a thin fan. So this will be a controller powered fan. Sorry, something rattled over. We have one more fan port It's fan what 012. So we can use this. Is pinned out correctly. So I'm just going to slip this into fan 2 for now. This is just going to come over here and we're going to mount it on this side because we're going to have all of our connections for our PSU over here. Or at least that is my plan. Will it clear? It will not. So this one's going to have to go in the front, but I do need to have it plugged in one way or the other before I put the fan on there so that I can be able to get to it. Basically what we're going to do is pull all of our power wires over to the side. Just going to basically push things down, but yeah, squish the wiring down so that we can get this put in place. Once again, the back of the PSU is going to touch top of my USB ports here. That's not going to be good. So I need to put some Captain tape on that to provide some type of insulating factor there. Just to keep metal from metal. Don't need to short any out. Short on. So all I'm going to do is run it completely down this edge. If I ever need to get in here and use these, the standard mounting holes, I can. That's no deal. Apparently can't run tape straight to. I think this used to be the stuff that we all put on our beds when back in the day to print on was Captain tape. I here had experience with that. I know I did. Captain tape is basically PEI. So It is a good insulator for electrical insulation. We used it a lot. We used to wrap hot ends in the stuff, um, old wires and things in. Got the back of that covered now, so I don't have to worry about sitting right up against there. I might roll some right over that edge there just to be on the safe side. Just to be on the safe side. Glad you got into printing after this. Yeah. And I mean this tape right here is pretty thin, um, compared to like a standard PI sheet or something. So it's nice because it can form around a bunch of things. But yeah, back in the day, that's what we do is use that stuff. Now these, I'm probably going to be looking at either 10s or 12s. Let me easily 12. Pulled 4 out, knowing that I do 3. So I am missing one of my screws, or not screws, but one of my mounts, and that is because the mount, believe it or not, there should have been a mirrored one, and there wasn't. So we're kind of stuck out to where we can only do 3 of the mounts. Um, and set up over here, wires. You guys watch me just comment about. Okay. So it helps put all the connections over at the side where you're going to be, where you're holding the wires with connections on them. Now, so the way this sits, as you can tell, it is offset, and stop trying to put a screw into a screw in. Leveling, yeah. Yeah, leveling with Captain. I mean, that's one thing that you could do is you could use Captain tape underneath your bed to try and help deal with any warps and stuff. This one's not lining up, but got crosslink. I can't get this one to line up. Still be good. There you go. You locked down. What we need to do now is do our power connections. So our line, neutral, and ground is down here. Our line is red. Live. Neutral. Black. Ground or earth, which would be the yellow green. And then white's hot and blue is cold. White is hot, so that would be our positive. Blue is cold, that'll be our negative. Okay. We can over on side real fast. We'll have to clean up some wires. I'm going to try and install this right here real fast. Couple of M3 nuts and probably some M3 by 8s. Or black one. Okay. One up, one down. Normally I wouldn't worry about this, but because we've got a fan in it, I'll go ahead and try and install it. And the other thing that I probably should have done, didn't, now it's going to be a pain in the tuchus, would be wiring up our screen. So the nice thing is our screen will mount right from the front here. So it'll sit up a little bit and it won't, we'll have the fan that can still pull air in behind it and won't give us any troubles. So we'll be able to get that but I believe we are all connected now and we can do a power test to see if we've got appropriate connectivity everywhere and we don't set anything on fire. Preferably not set anything on fire. So I am in the OFF position. I am going to plug our power in. You guys ready? Are you guys ready? Let me just make sure that clearance. We're not touching the ground with our power supply. Got 2 more skirts that we put in place. We probably want to go ahead and put this on our connectors. Cover those up. So my screws, I used M4 by 12s to mount the power supply, or to mount the mounts to the power supply. And first you might go, well, wow, that's extra long. But while that is a true statement, we do have plenty of room in these power supplies for that. So In fact, I could, where these are at in the holes on here, I could probably run like M4 by 1820s without having to worry about running it anything critical that could. Here we go. Three of four in. Move that stuff out of the way. You want to see the bottom, or do you want to see the what do you guys want to see? What do you guys want to see as far as did we set anything on fire? Let's do the bottom. You're not going to see any lights, I don't think. See these lights. Have light here. Yep, got power lights coming on. Normally you would see a screen, but I'm going to have to take the power supply back off in order to insert my cable into the screen. Let's see. What's up? Well, I just heard fans kick on. And we're taking an error. ADC out of range. So there's something with the ADC. I know that we had good ADC down below. So it's got to be the one that I just did up here for the thermistor. So I'm going to have to try and reflow these. Good news is we're good. Bad news is we just need to rehit some of our solder joints. Okay. Power off. Unplug cable. Look at solder joint. So I know that everything was coming up right on my config because we did that beforehand, right? We showed that the config's good by plugging in a thermistor. Knew we were good. So just a matter of making sure that these are properly flowed. That's good. I think other side. Other problem on. Buy some power again. See if we get a better response system. Hey, how's it going, Pete? Welcome in. Welcome in. Be posting cosmetically updated Rook parts on printable soon. Cool. Okay, so ADC still out of range. So I know this one looks visibly good. The other one, I think it's this one, this you. I'm gonna have to redo that one. Cut off that. No idea where that. Okay. So one of those. Try that again. And this is an issue of small, tiny connectors and trying to get things lined up. That should be good. I'm hoping. If not, well, it might be another stream still to get us printing. So I'll have to work on it afterwards. I'm going to have to take stuff on the toolhead back apart to get, or at least move this out of the way to get a little bit more access. So how's it going, Pete? Doing good? You guys remember I was printing this off on one of the last streams. Got several maker chips in here. Rocky Mountain, KB3D, Pez Liz, Pete Savas, reprinted 3D. The original Digital Dragon coin, Big Jano, Polymakers, 3D Medic Vents, Joe Mike Makes, Zombie Hedgehog, K2, Built Over Bot, Blendin 3D, Royal Nomi, Karen Chow Designs, Maker Mashup, Maker Deck, and Silverback. So I think I've got more. I'm still looking through. I think Miss Dragon may have a stash somewhere as well. There's a printable cap to put on top so you don't knock it over and it goes everywhere. That probably would not be a bad thing, especially if it somehow kind of slips on into the slot. Either that or if it's TPU and it's a good tight press fit. That would be good as well. Or a fan kick. Did turn the power on, right? Yes, I did. Hey, uh-oh, what is this? What is this? We're up and running. Well, I'll be darned. Which means what? We're going to come in here to our maker resource. And we're going to scroll down here. Or where? Well, sucky. All right. So Voron Design. And just like everything else, I always come over here to the Voron documentation because it's easy. It always works. If I make a work, I need it. How many times have you knocked yours over trying to reach for it and show it on stream, Liz? We're going to come down here, build, go to initial startup. Okay. So we've shown that we can get into the system. That part's good. A couple of the things that we're going to start with here. You know, we got into the system going. We want to make sure that our temperatures are reading. And as we saw earlier, we are getting temperature readout, right? So we've got temp showing. That's good. So now that we've got temperature showing, what we're really going to need to do is look at if I tell it to start heating up a heater, does it heat up? So got temperature reading. They appear to be very close to one another around both of our thermistors. So good there. Going to tell it to warm up one of our heaters and see if we can get a heater to start heating up. We'll do it one at a time. We're not looking for full heat. We just want to make sure that the heaters will warm. So we're going to come in here, tell our extruder heat, go to say 60. And the good thing is our fan kicked on, and it's the correct fan. It's the fan on the side here kicked on, right? Because we told it to go up above 50. And hit 60-ish, so it overran, which is fine. We're going to have to tune that. Now we're going to tell it to go back to 0. And this fan should keep going until we drop below 50. Drop below 50, the fan should drop off. There we go. Fan turned off at 50. Now let's come in here and tell it to heat that up to 60. And I'm not going to let it heat. I'm just going to rest my hand here and start feeling for what it is. Is rising and feel warmth on my, so I'm getting tactile confirmation of what I'm seeing here with temperature. I'm not going to go ahead and let this. So we've got 2. We're for 4 now. Temperatures are working. That's good. Now we want to try and do a stepper motor. Kind of move that in the middle. And before I forget it, we know that we still need a little bit of tension on our Z-axis. So let's go ahead and put some screws in here and try and raise that up some. It's said to go with M316. I think I'm going to need that much to start with, so I'm going to go with some M3 by 12s. And the big thing here is trying to get consistency around the 4 screws. So all I'm going to do is get them going in there until I feel them bottom out on the extruder. How's it going, Jedi Spidey? Doing good. And the only thing I don't like about this method is we're going to mar the extrusions. It's the easiest way to do it, but we're going to mar the extrusion. So what I'm going to do is slowly, I'm going to do all 4 in a crisscrossing pattern. So turn, turn, because what I don't want is one side to be kind of lopsided. close there for quarter turn. Okay, I think that's going to be good there. Now we need to figure out our stepper motor. Do our stepper buzz, and I believe this, the way I've done it in the past is looked at as if it's V0 because motors are in the back, tensions in the front, motors are in the back. This is basically a V0 in a different form, right? In fact, we're using a V0 bed. So in stepper X, or when we do a stepper X, our X motor or B motor should move clockwise, then counterclockwise. As we're looking at the top of the motor, we go to the right and then to the, okay? So we're going to copy the stepper buzz command. Paste this over here and run it. And look at our pulley. So we bring you guys over here so we can look at this pulley. And hopefully you can see that it's going right then left. Give me 1 second here. No real good place to set you guys down. Give me 1 second. Grab marker. I'm going to put a mark on. See, it's going clockwise and counterclockwise. That's correct movement. Do the same thing over here. I'm going to run a stepper buzz Y. That's going clockwise and counterclockwise, right? And that's exactly what it says we should be doing. Guys, back up. Get a couple of things out of the way fast. Okay. Now our Z-axis, I'm going to try and lift this up some if it let me, because it was all the way down at the bottom. Lifted that up some, and our Z-axis, it should move downward and back up. This is one I'm not sure if it's going in the right direction. A different mechanism I had on the. And it is going in the right direction. So that's good. The extruder, we can see the extruder here. So we'll be able to tell if it is going in the let me see if I can see that one. Unknown stepper. because it's just called extruder. That makes Pepper Buzz extruder. It should be going, this is going backwards. So it should be, movement direction will be tested later. It's going in the wrong direction, right? Because it should have went in and then out, in and out. And with the way it was going, it would have been retract, load, retract, and so watch this gear on the left. See how it goes out then in based on the gear hole right there? That tells me it's retracting and then loading, retracting and then loading. That's going in the wrong direction. So we need to change the direction of the extruder. Good thing to know. We're going to hold off on making that change, but we are going to need. I think the next thing we're going to do is in-stop check. Yes. So we're doing sensorless homing on X and Y. So we're not going to be able to query those in-stops at this. Query in-stop command. You can also copy this, run this. And right now, X is open, Y is open, Z is open. I'm going to reach down here and press Z. Do an up arrow, send that again. Z is now triggered, so that's good. The other way that you can verify that is to go into the machine tab, scroll down to the bottom, and end stops down here. Hit refresh. This goes through and says, okay, none of your end stops are triggered. Trigger the Z again, refresh. Now you see triggered. Refresh again, and so same thing. In fact, it should be running basically when you're doing that refresh. In the background, it's doing a query instance. Okay. So our in stops appear to be good. Once again, we're doing sensorless homing on X and Y. So you'd be ready to quickly stop if it's going in the wrong direction. Yes, yes, yes. Stepper motor X is B, one Y, motor A, which is right, figured right. And what we're going to do is we're going to try and do a X home X, drop the bed down, and then home the X to the right. Did. Home Y, drop the bed down, and then move to the back. And it did, but I don't know if you heard it, but when it hit the back, so when it went to the right, it hit, and it was kind of silent. When it hit the back a little hard. So we can adjust our sensitivity, like very minor. So I'm going to come in here to machine printer config. I'm going to do a couple of things. X, we were doing, we did good. Like the way X hit and sounded. By the way, the input shaper values are from my Rook 2020 downstate. So I pulled those over. Same thing on my Stepper X. Got the run current and our our driver SGHRF. This is our stall guard threshold set to 110 for the right. Hit the side, immediately stopped, good. On our Y stepper, our driver threshold was also 1. I had it at 145 down. So on the other Rook, so I'm going to slowly move this up a little bit at a time and take it up to 115. We're going to keep testing that and trying it as we're doing other things the right direction. But as we come in here and make other changes, start in so that we can get it to hit the back without hammering back too much. I'm going to increase that in short jumps. I'm not going to jump it way. Since we're in here making changes, change the direction of our. We're going to come in here and just take the exclamation point. And that's all we're going to do right now. While that's restarting, I'm head, lead. Okay. And we had checked everything out before. We and X and Y. That was going good. I think now we want to do the full month and try and home all. Home all. Right, left, going all the way down to the Z, E. Boom, we're now. Go ahead and turn the motors off. Raise this up manually slightly. I want to scoot this over. I'm going to run that again because I wasn't paying attention to how hard it hit back here, so I just verify that again as it does a full home. Quiet. So it's still hitting back here a little bit hard, so we can make that adjustment. Take that up a little bit more on our Y-axis. Still hitting a little bit hard, so I am take this. Save and restart. Chance to move things off the end stops. Them all. So it's still hitting pretty decently. So I am going to go ahead and jump it up to 1.5 now. Which is, like I said, where I have it on the other. I'm just going to save. I want to go ahead and continue. Now we need to do bed locating. So what we need to do is try and get to 0, 0 in this front left. Trying to make sure and get a proper 0, 0 and max. So X, Y, X, stop position. So here's something to note. Um, Currently, my positions are based on my machine downstairs. I cannot guarantee that my Z stop is in the spot. So I do need to validate my Z and get it close. Also, I'm running a spot end. The distance right here between the gantry and the head may be different as well. Same thing for the X and Y. So what I need to do is I've homed the printer and it's done a little bit of a back off. It says I'm at 112 and 105 Y direction. But I need to get my somewhat. So we're going to try and move our Z up. This Z motor is not moving as far as it should be. Makes me wonder if I've got a 0.9 motor. I have Z because it thinks it's already traveled almost all the way. Or micro. Okay, so what I need to do is grab is the full steps per rotation, pull it down. Just to make sure that I have it here. So save and restart. I have a feeling that um, my Z is not the rotation distance, but I don't think I can see the motor. Yeah, it's a standard roll or branded roll-on, so I can't tell if it's a 0.9. Was the same Z printer? Can't tell if it was. Go ahead and home all again. I think I just realized what the problem was. So we're going from a 20 tooth to an 80 tooth. Yes, that 80 tooth is driving the 20 tooth, but it's at an 80. So I need to add a gear ratio. That's the issue. So similar to an extruder, you have a gear ratio here. We'll have a gear ratio on our Z drive. We're 8.5 and a 50, and 22 driving an 80. Whoops. Twenty-two driving an 82. Because basically, it's this Z setup is just like a 2.4, right? It's basically what we've got going on here. 2. Really wish I could figure out why this key. Finds verify information out. Yeah, what I'm going to do is I want to verify something off the 2.4 because, like I said, we're basically using a 2.4 Z-axis gearing in this printer, and I guess I just want to make sure that we're figured it basically the same way. So, because right now we're definitely not getting the right travel distance that we're asking for. I didn't think. By any chance? Didn't. No, it was 11 doing. So let's check our mission distance, 40 gear ratio. Is a 80 to 64. A little bit. It'll be 320. Good news is I think we got our y-axis super quiet. Nope, that didn't work. Axis is 2 cents. So one thing of note, whenever you're dealing with sensorless homing, um, with sensorless homing, anytime you change motor power or speed, like homing speed, it's going to impact your sensorless homing right? Because you're going either more power or you're going faster into that end stop, and it's going to change your stall guard threshold. So be very careful of that. You know, if your motors are starting to get warm, you'll want to change your network. you'll want to change your settings, right, for your motor, but just be aware that it's going to impact um, felt like it. That is an 8. Another restart. Up those new settings. Sorry, folks. I know this is kind of going slow and probably somewhat boring. Trying to get our initial setup going. Trying to make sure that if I call for 25, I'm getting. What I'm trying to do is just get the close. Go past that. I have a lot more Z. I measure that. Now what I'm going to try and do is we're going to try and locate our nozzle tip to the build plate. So actually going to try and go to zero, zero. Okay, so this is where it currently feels it is at 0, 0. Go ahead and bring my as far as it'll let me, and that's as far as it's going to let me. And I can do some measurement to see about how far I am off of this front corner. 6 mil. So I can do positive 6 in the X, and we're going to call Y good. I need something smaller to try and figure out how much more Z I've got. About how much do I have? Need to add about another 10 mil to Z and 6 mil to Y, or I'm sorry, X. So we're here to machine printer. When we home X, we need to increase our max for homing. So position end stop will be +6, 123. Means we also want to tell max X position is 120. And for our Z, our position end stop of actually down here. Go ahead and add 10 to it. Make that 117. Says not to mess with that. We'll be okay. We'll be okay. Save and restart. Position end stop. So what we just did was locate our 0 point, that on and stop looking. Okay, so 02, the end stop is looking. We'll work on. Oh, now that's what we're going to do is verify our Z. So what we're going to do is home all again. Sorry, everybody. Feels it's at 117.75. Start bringing it up and get close. 425s will be somewhat close. Now I'm going to try and go ahead and bring it closer, but I also want to move my X and what I'm going to do is do a E1 X to 55 Y 50 D move to the somewhere in the center, come up a little bit closer. And here's the reason is as I go to do this next command, which is going to be the in stop count, it's going to require me to raise this up and down a little bit at a time. The closer I am, like the last thing you want to do is home down here and run ZN stop calibrate because you can't do large chunks. So trying to get it up here, you're going at like very small increments at a time. Try and get up as close as possible. Start with, eyeball it, start getting it closer. Zero, negative, may not be close enough. May have to. So we're going to do in stop calibrate. Bring up this whole macro dude to out. It's going to pop up and already at -1. We're obviously not close, right? So I'm going to go ahead and keep using this. Scaled because I am still far. I don't have enough adjustment room. So let me back into machine. Stepper Z at 120. At 125. Now we're doing this cold, and what I always do is I do it cold, get my bed adjusted. I can do it hot at normal printing temp. That will help dial things. To them all again. One X 55 Y 50 5. That gets us close. Okay. So our Z in stock calibrate from here. And we're pretty close. Apparently, not really. Max. Not. Ah. It's the max position. Get it figured out here in a second. Get this done. We'll go ahead and jump out. So I want to try and get this command done and show everybody. Close. Start getting closer. On our in stock calibrate again. Close. I'm going to start going in 0.1 increment. Starting to feel a drag, so I'll go down to 0.5. Definitely drag, so I'll back up. Right there. Up that. And it has now calculated that my stepper Z position in stop is 121.594. So when I save that config, it's going to go ahead and add that in. Now knows distance from the nozzle down to the end. So that's what we were trying to do there, is set that. So we would save that config and let it reboot. Now, probe. It would be PID tuning. And quite honestly, folks, I'm going to PID tune this off stream here. It's getting to be about that time. I need to grab some dinner. Now that it's 10:30. Thank you everybody for being here and hanging out with me tonight. You that stuck around all this long. I know it was we've gone a little over 4 hours. We had some issues initially. I'm going to try and work through that. I don't know if it's my own fault. I did a Windows 11 update. I think is impacting some things, but I also updated OBS. Now I don't know is it I don't know. I'm going to have to test out some of my other windows or scenes and figure out what's going on with this. I think working in some scenes. With that, let me go ahead Thursday night, so normally Big Jano, but ends is everybody feel like, or do I have a preference? Go tonight. Go over and bug Higgins and Road. Stayed on long for a big. Not seeing. Okay. Well, it sounds like, or seems like, kind of lost a lot of you. Probably multiple tabbing it. I'm gonna go ahead and get it over. Like I said, he is live right now, driving through the night. Go over and keep him company and wake. And thank you everybody for being here. Please go with me as we go on this raid. Hey, Gulsifer. We are getting some movement. We did just set our offset, basically. So I am going to pid tune this off stream. But thanks a lot for being here. Working on steel stuff. Nice. But I'm going to go ahead and get this raid started over to Shenanigans. Like I said, let's hang out with him. Driving. We'll come back Thursday, and we should see Filament pushing through this Thursday night. So thanks a lot, everybody. Have a good one. Hey, Chewy. Yeah, I need to tune it. I need to pid tune it. I'll pid tune it off stream, and then we can start trying to get a print running through. Thanks a lot, everybody. Have a great night. We'll see you guys on Thursday. Bye now.